Welcome to the Automotive Diagnostic Podcast. We're going to explore ways to sharpen our diagnostic skills, find learning resources, and hear from experts in the automotive field. Hey, what's going on, automotive world? Welcome to another episode of the Automotive Diagnostic Podcast. My name is Sean Tipping, and I'll be your host once again for this week's episode. You got just me this week. I'm going to talk about Magneto Resistive speed sensors used in automotive applications. I get a lot of calls on really wheel speed sensors is where the main focus is going to be, but you could apply this to other areas of the vehicle as these speed sensors are applied in other areas like transmission and engine in certain applications. But the big ones, wheel speed sensors, that's going to be our focus today. Again, a lot of calls on these and techs get kind of beat up. And usually the scenario is, hey, we replaced the sensor. Maybe we replaced the sensor twice and we're still getting the same code, and then, diving in and figuring it out. I'm also going to take the time to explain the sensor a little bit. It was actually almost a year ago, episode 119. I did a sensor series episode on the VR, variable reluctance sensors, which is a two-wire sensor, like we're going to see with these MR style sensors. But the VR sensor is a two-wire sensor, creates its own voltage and measures speed and rotation. Again, wheel speed sensors, we see those in crankshaft, camshaft applications on older vehicles. And since then, most manufacturers have adopted either Hall effect or the ones we're going to be talking about today, which are the MR style sensors. The Magneto Resistive or MR style is actually similar in the output that you see to a Hall effect, in the sense that they're both digital square waves, whereas our VR sensor is an analog signal. There is definitely a difference in how the sensor operates and a little bit of a difference in how we're going to assess the circuit. But you could think of Hall effect and MR both as digital sensors and the VR as an analog sensor. So again, if you want more information on that VR analog style for the older vehicles, and we still do see some VR sensors used maybe I shouldn't even say modern vehicles, but vehicles that are still out on the road, we do run into some VR sensors here and there. That's episode 119. I'll put the link in the show notes for that. This episode kind of is the progression of that. I did sort of skip over Hall effect sensors. Me and Brian Mann were actually going to do an episode on that at some point or another, so that will probably be the third one in this series. But for today, I wanted to cover the Magneto Resistive style. Again, lots of calls on these. So let's talk about the sensor itself a little bit here. First thing I'll put out there to everybody is it's actually pretty complex what's happening in the sensor. And I want to be very transparent that I'm not the authority on all of the different components within the MR sensor and how they function. I'm actually going to include a link in the show notes to an article that was written by Bernie Thompson. And it's very technical in nature, but explains the operation of these sensors more in depth than I'm going to do here. One, because you can use visuals in an article like that, but also he's got pretty good knowledge on the inner workings of these sensors, whereas mine is minimal, only enough in order to diagnose these sensors, right? Because that's my goal, is let's assess these sensors, are they working or not, and have a basic idea of how they function. Now, I've read up on the technical function of these sensors, and we'll talk a little bit about it here, but I like to boil things down to what's applicable in the real world and what are the effective testing methods. How much do I need to know about the function of this sensor in order to do my job? And that's really what I'm after, and that's what I'm going to share with you today. So again, MRE or MR style sensors, Magneto Resistive. Typically, we're going to see these with 2 wires, but do be aware that they can use 3 wires in some applications. I've never seen this in a wheel speed sensor application. All of the MR style sensors I've seen used it in a wheel speed sensor use 2 wires. Now, these often get confused or maybe not even confusion, just assumed that they're the same as the old style sensors, the VR sensors, because those use 2 wires as well. Well, if we're to look at the signal that's outputted from these sensors, or even look at the tone wheel of most of these sensors, it's very different. And so it is important to know the difference, and especially for testing, they're in no way the same for testing as far as assessing is the sensor functioning or what is the signal coming out of the sensor. Very different between the two, but they both do have 2 wires. Typically, these MR style sensors are going to be much smaller in size in comparison to the old school VR sensors. Now, that's not a 100% way to identify one or the other. I would use service information to figure out what you're dealing with. But if you've seen enough VR and you've seen some MR style sensors, you can a lot of the time pick out which one's which just by the size of the sensor. So something to look at, but it's not an end all be all. Check your service information to see what you're working on. So what do we mean when we say magneto resistive? Magneto resistance is the ability of a material to change its electrical resistance when exposed to an external magnetic field. When the force of the magnetic field is parallel to the current flow through this material, the resistance of the conductor increases, and when the field moves to a 90-degree angle, the resistance decreases. So, in Sean tipping terms, the movement of a magnetic field past the sensor is going to change the resistivity or the amount of resistance that it has. Okay, so there's a magneto resistive element within these sensors, and I'll put a picture in the Facebook group. It's actually a diagram of the inside of an example of an MRE sensor. And there's a whole bunch of stuff going on in there, like amplifiers and Schmitt triggers. And again, stuff that I'm lacking on information, but also don't really care that much. But within there, what I do want to know is that there's an element that is going to change its resistance based on the orientation of a magnetic field in close proximity to the end of that sensor. Okay, so it's going to have this magneto resistive element. It's going to have some monitoring or measuring circuitry within the sensor, and then it's going to output a signal to the control module. And that's really what I'm concerned about, is what's coming out of this sensor and when, and what is the sensor actually looking for? How is it going to change based on the circumstances? What happens during a fault? How do I assess the circuit? These are the sort of things that I really want to know, as opposed to how do all the inner workings of the sensor work, right? But again, we're going to produce a signal out of the sensor based on a magnetic field. Now, if we go back to our VR sensor, if we talk about Hall effect sensors, it's all kind of the same thing. We're dealing with a changing magnetic field that outputs a signal. MR sensors, we're just doing this a little bit differently. They're going to be more accurate at slower speeds than a VR sensor because, technically speaking, we don't need a moving wheel to output a signal from an MR sensor. With a VR style sensor, the amplitude of the sensor being output all depends on the speed of the wheel or moving component, whatever it is. And if we slow almost to a stop, we're not really moving that magnetic field. The VR sensor is not going to be producing much of a signal. And so at slow speeds, they're not very effective. Whereas Hall effect or the MR style that we're talking about today, very effective at low speeds, really, again, technically don't need movement to produce a signal, right? If that wheel stops, and on these sensors, we're going to have a magnetic tone wheel with north and south poles. If we stop at a certain point, that sensor will still output a signal, either a high or low voltage, depending on where it stops, right? And so we're accurate all the way to a stop. And that's one of the advantages of these sensors. So again, what we see going to this sensor is 2 wires, and we're going to have a voltage supply going to one of these sensors. And that is one of the big differences in one of the ways you can identify one of these sensors if you're looking at the circuitry in comparison to a VR style sensor, because the VR sensors don't have, or I should say don't need, a voltage supply from the module in order to generate a signal. The VR sensors generate their own voltage. So you could have it unplugged from the module, spin the wheel, and you'll still get a signal out of it. Not the case with an MR style sensor. It has to have a voltage supply provided by the control module in order to operate. All that monitoring circuitry inside of the sensor needs a voltage supply in order to do its thing. So that is one difference. And again, one way that you might be able to identify what type of sensor you have. Of course, there's variables on all that stuff. There are some VR style sensors that use a bias voltage for circuit integrity. So you could get confused there. So anyways, I don't want to derail it with all the different possibilities of circuit configuration, but you're going to see a power supply, a voltage supply to one of these sensors. A lot of the time, we're going to see this close to battery voltage, although again, it doesn't need to be. It's whatever voltage the manufacturer determines is going to be on that sensor. But there will be a voltage supply, and then there's going to be a ground on the other side of the sensor, right? So we have voltage supply and a ground. Now, the monitoring for the circuit can happen on either the voltage supply side or on the ground side, again, depending on the circuit configuration, right? When we start talking about anything on cars, of course, there's always a it depends answer to things, and you're going to have to look at the specific car that you're working on. All the vehicles that we talk about today, the actual circuit monitoring, and what I mean by that is where is the control module looking to determine what's going on with the circuit, or maybe I should even say where we are going to be looking to monitor the output of the sensor is going to be on the power supply side. But again, it doesn't have to be. But when we look at the voltage supply going to that sensor on one of the wires, and we rotate the wheel or we move whatever rotating component is going to be rotating, with the module turned on, supplying voltage to the sensor, and everything connected, we should see a changing in the voltage on that supply side. Now, it's not going to be big. Sometimes this is only a volt or less of change, but it is going to go from one voltage to another voltage. So it's going to be a digital signal. Think on, off, think square wave. That's what you're going to be seeing if we scope this circuit. And how you would do that is grounding your scope and then connecting it to the voltage supply or the positive side of the circuit. A lot of times in the diagrams, you're just going to see plus and minus on the diagram itself. And you're going to be connecting to the positive side of this circuit. Again, based on some diagrams that I've seen, sometimes the monitoring is done on the ground side, but all the ones we deal with today will be looking at the positive side of the circuit. But as that wheel changes, we see a change in the voltage on that supply side. Again, not much, creates a square wave, but we see this as a voltage change. Now, to be technically correct, the control module is actually going to be measuring the current that goes through this sensor. And when I say current, it's very, very small amount of current that's going through this sensor. I'm talking like 7 to 14 milliamps. And I don't use current as a measurement for one of these sensors, but you could. If you had a micro amp clamp for a scope that measures milliamps very accurately down to a very small amount, you could use current in this circuit and monitor, and you'd get a similar square wave, but it's going to be in milliamps instead of voltage. But me personally, what I do on these sensors is I use the voltage on the supply side, and it's going to show me a very similar square wave just in voltage. And again, the module's going to be measuring current through this sensor, and we'll talk a little bit about what's happening there. But I guess if you really dig deep into it, it's using voltage to infer current. So if I'm measuring voltage, I'm happy with that. So anyways, I don't want to muddy the waters too much, and without visuals might be a little tough to follow, but I'm going to be watching the voltage on the power, the positive side of this circuit to this sensor, and I'm going to be watching for a changing square wave as my component rotates, as my wheel spins, is again what we're dealing with mostly here today. But keep in mind that square wave doesn't drop all the way down to zero. It's going to be a small change. You're going to see a small square wave on the scope if you're looking at it, and that's completely normal. But I want to present something to you to help you understand what's actually happening in the circuit. And I realize that it's going to be an oversimplified version of this sensor operation. I get that. But when I was teaching these sensors at the college, and when we go through VR, Hall effect, and MR style sensors, I found that this was the easiest way for students to wrap their heads around how this sensor is functioning and what they're actually seeing on the scope, what's actually happening in the circuit. And I know that there's more complexity going on within the sensor and the circuit in the computer, but for us, again, for determining circuit integrity, for determining whether the sensor is functioning or outputting a signal or not, this, I think, is going to be the easiest way to think about the sensor as you're looking at it. So let's start with this. I want you to picture a thermistor circuit in your head. And most of us are very familiar with a typical thermistor circuit, right? You have a control module. It's going to be outputting a fixed 5-volt reference. It's going to go through a fixed resistor in the control module, right? So we have 5-volt reference, fixed resistor, meaning it does not change in resistance. It will exit the module on a wire. This would be our signal wire. That signal wire will connect to the thermistor, or we could say a variable resistor. And then on the other side of that variable resistor or thermistor, we have a wire that goes back to the control module and is grounded, right? So that's our thermistor circuit. Now, the control module is going to look at the voltage between those two resistors, right? Our signal wire is between the fixed resistor in the module and the variable resistor or the thermistor that's going to change in resistance with temperature, right? So as the temperature changes, our resistance changes, and that voltage in between the fixed resistor and the variable resistor changes in turn. The computer determines, okay, this voltage equals this temperature. It's programmed in to know that when this voltage is present, this temperature is present. Now, if you were to look at this on a scope or a graph, you'd see an analog signal, right? You'd see it changing tenths of a volt at a time, and it would be a slow ramp up or down depending on which way the temperature goes, okay? That's a very simple circuit, but that's what I want you to picture in your head here. Because if we think about one of these MR-style sensors in the same way, it makes it a lot easier to wrap your head around what's going on with the circuit. Now, in an MR-style sensor, think of the setup almost exactly the same, right? We have a voltage supply. Now, in most cases, this is not 5 volts. This is going to be something that can be closer to battery voltage, but it's still a supply voltage. And it's still going to be going through some monitoring circuitry. In the case of the thermistor, you can think of a fixed resistor. I realize in the case of an MRE style sensor, that may not be exactly what it is, but it's going to be going through some monitoring resistance or components within the control module, and then it's going to exit and go out to our MR style sensor, which you can think of as a variable resistor, okay? And then the other wire is going to go back to the module and get grounded, just like a thermistor. Now, here's the difference with the MR style sensor that we need to understand is that it's our variable resistor, like our thermistor is, but it only has one of two states, right? And I'm going to make up some numbers here, but let's just say 100 ohms or 200 ohms, right? The resistance, it's an MR, Magneto Resistive, but the resistance of that sensor can change from 100 or 200, and that's it. And the computer is going to watch the voltage between the supply and the variable resistor. And as that variable resistor changes, it will change the voltage on that signal wire, and it will determine the position of that rotating component, right? So in my mind, that makes it very easy to understand what's happening with the sensor. It's just like a thermistor, and it's just going from one or two states rather than a variable voltage between 0 and 5 like a thermistor. Now, I get that's oversimplifying what's actually happening. And I get that the computer is actually looking at current, and I get that it's not exactly the same circuit setup, but I find it helpful to reference something that I'm very familiar with to help me with something that's maybe more complex or I'm less familiar with. And when we're looking at it with a scope and we're watching that signal wire, we can think of it that way, and it works really well to say, hey, is the circuit working or not? Is that sensor changing in its resistance value the way we would expect it to as that magnetic tone wheel is moving past it, north and south poles, changing the orientation of the magnetic field to the Magneto Resistive element, in turn changing the voltage that we see on our signal wire. right? That creates our square wave. That's it. So think of it as a thermistor with one of two states, and it's going to change our voltage on our signal wire to one of two states, making a square wave. Hopefully that makes sense. So all three of the short case studies that I'm going to share with you today on vehicles to talk about these sensors are going to involve wheel speed sensors. I realize these can be used in other applications, but a lot of the time, this is where we see them, and that's where I get the calls too. Just a couple things to note before we jump into them, though. Again, most of these are going to use magnetic tone wheels for referencing the position of the wheel. Doesn't absolutely have to. The MR style sensor can have a magnet located within it. We can use a traditional metal tone wheel, but again, for most of them that I see with wheel speed sensor applications, it's going to have a magnetic tone wheel that's going to be built on to the wheel hub in some fashion. Now, this is one area that we want to see if that magnetic tone wheel is intact. The GM wheel bearings, it can actually crack and fall off. The tone wheel portion will just fall off and go away, or it'll be broken into pieces, and that can obviously create codes and wheel speed sensor issues. So if you can do a visual check of that tone wheel to see if it's functioning. Honda was one of the first ones where I would run into these sensors. They were using these sensors very early on, and the wheel bearing that was pressed into the hub had a magnetic tone wheel that was built into the bearing, right? And you could put the bearing in either way, right? You could flip the bearing around and press it into the hub, and the magnetic tone wheel would be then facing the outside, the wheel side, rather than the inside and the sensor side. And then you go drive it and there's no output from that wheel speed sensor. But the problem was you put the wheel bearing in backwards, right? We saw that a lot. So I would always take a paper clip and make sure that, okay, it sticks to this side of the wheel bearing. That's my magnetic tone wheel. I got to make sure that faces the sensor when I assemble this hub assembly, right? So things like that, we want to make sure that the tone wheel is intact and there in order for the sensor to register anything. One quick way that you can assess this, if you're not sure, I don't understand how this tone wheel works. I don't know if it's there. I don't know if it's correct, whatever. You can remove the sensor from its housing and you can move a magnet past it. You can be the tone wheel and then monitor the circuit with a scope and see if it changes states. And that would prove that, okay, the sensor's working, the sensor's doing what it's supposed to. I need to really look closely at my tone wheel. And I've done that before and it works pretty well. I also should mention there, I'm going to be talking about looking at the signal. I am using a scope in most cases with these, and I'm going to use a U-scope 99% of the time. You can definitely use a Pico and get a better picture, but the U-scope does the trick on these. Single channel scope, easy connection, it's right there, and you can see this square wave. So anyways, when I talk about scoping, I'm looking at that signal wire as I'm changing states of the tone wheel or the wheel itself. The other thing I wanted to mention as we get into some testing methods for these sensors is that if the circuit is disconnected in a lot of applications, I'm thinking of GM vehicles specifically between 07 and 13. I say that because there's a service bulletin about this. If the circuit is disconnected in a lot of applications, the vehicles will actually turn off the supply voltage to this sensor once a circuit problem has been identified. I'll reference this TSB in the show notes as well, because it actually includes a method that you can use to test a wheel speed sensor. They call these active wheel speed sensor or an MR style sensor, using a ammeter in series with a resistor and the sensor and using a battery. And there's a diagram in this TSB, but the main point of the TSB is when you disconnect or there's just a circuit problem, there's an open in the wire somewhere, the module will see that, set a circuit code, and that's kind of your giveaway here, but it will disable the supply voltage to that circuit. So there was a lot of EBCMs and these GMs being replaced unnecessarily because techs would look at this, they say, well, there's no voltage coming out of the ABS unit. Okay, let's replace the unit. It does the same thing. When this circuit code sets, it is by design that it shuts down the power supply. Here's the giveaway, and they list this out on the TSB. Cycle the ignition while watching the supply side of the circuit with a scope. And what you should see is a 12-volt pulse for a very brief period of time as the module is going to assess the circuit one more time and say, hey, is my circuit fault still there? And if it's not, it will continue supplying voltage. If it is, it shuts it off again. So if you're not looking at it with a scope or something that can catch a very quick pulse, you're not going to see that. But if that's there, the computer is probably accurate in determining there is a circuit problem, and now you need to go find it. Okay. But here's the other thing that can happen. Maybe you unplug a wheel speed sensor for testing, and you don't realize that now that has shut off the supply voltage to that sensor. Okay. And GM's not the only one that does this. There's other manufacturers as well, but it's the one that comes to mind. And again, there's a service bulletin referencing this saying, hey, don't replace the ABS module here. This is normal circuit operation. The codes you give away, the 12-volt pulse is your giveaway. So make sure to be aware of that as we get into testing, because we do disconnect the sensors for various reasons. Now, not all vehicles do this. And actually, all three of the vehicles I mentioned today do not do this. So there's a lot of variability out there, and you're going to have to take things case by case. Okay, first vehicle I want to go through, and each one of these illustrates a potential problem that you can see with MR style sensors. This first one's a pretty common one. I've seen this a number of times over the years. 2008 Nissan Pathfinder. This was setting a code for the right front wheel speed sensor, and it was a circuit code. You will see most of these are circuit codes. So this is a code that would actually set as soon as you key up the vehicle. You don't even have to drive it. Okay. And most of the time, we can assume as technicians that this is an actual circuit electrical problem that the ABS module is determining. And so you may not even have to drive the vehicle in this case. We need to really assess the circuit. Okay. Now there's codes where it can be in reference to no output from the wheel speed sensor after the vehicle's been driven. Obviously different codes. That's not this. This is a circuit code as soon as I key this thing up. Now the original concern, the actual reason I was called to look at this Pathfinder was because there was no 4x4 operation, no four-wheel drive. Well, the way this works is if there's an issue with the ABS or the wheel speed sensors, this vehicle will not allow 4x4 operation. So I quickly went from looking at the 4x4 to looking at this ABS system and the right front wheel speed sensor circuit code and what's going on with that. So I'm going to go to this sensor, and first things first, I'm going to measure what the voltages are, what's on both circuits with the sensor plugged in. I want to see what's going on here, why this is setting a circuit code. So on one side of this sensor, I have a ground, and I'm going to note this a number of times throughout the vehicles. This ground lights a test light. I find it's very common. I'm sure it's not all vehicles, but it's very common on the ground side of these sensors, the negative side. If you were to look at a diagram, if you power up a test light, it will light up that test light. So that is a straight shot to ground, and that's normal. And again, all the applications I'm going to talk about today, including this Nissan Pathfinder. Okay, and that's what we want to see. And I'm also going to reference this quite a bit. If I check the good side, and it's one of the powerful tools about looking at wheel speed sensors, is you have potentially 3 other sensors that are working properly that you can compare to. I see that full ground that lights a test light on that side as well. On the positive side of the circuit, however, looking at it with my U-scope, I only have 1 volt. Okay. If I look at the good side of this vehicle, because I can just bounce over to the left side and take a look, I have 12 volts or real close to battery voltage on my supply side. So right away, I've identified an issue. I've only have 1 volt here and I have 12 volts on the other. Okay. So now I'm going to unplug this sensor and see what happens with the sensor not connected. Do I still only have 1 volt here? So I do that, check on the supply side. Now I have battery voltage when the sensor's unplugged. Okay, so is this a bad sensor? Is that what's going on here? One of the things that we can do here is we can actually jump our harness side of the connector over to another sensor using I use a reel. It coils up the wires and it has alligator clips, or I actually have one with banana jacks as well. And I can jump the good sensor or sensor that's not sending a code to the harness on the side that has my circuit problem. And I like doing this. So I do this. I jump it to left front sensor to the right front harness, and I'm going to rescan for codes. And when I do this, it doesn't set the code anymore for the right front, meaning that the circuit all the way from the harness connector to the ABS module is good, essentially. And now my sensor is in question. But one thing I didn't mention yet is as I was doing this, I was using the diagram and I was looking at my sensor connector on the right front to determine, okay, which wire am I applying where to the left front sensor. I noticed that the colors were wrong, okay? Meaning that the positive on the diagram actually had my ground, and the negative on the diagram had my 12 volt supply. Now, if I connected it based on what was on the circuit, right? So I connected ground to what should be ground on the left side, and I connected positive to what should be positive on the left side, I was good. I didn't get a circuit code. If I flop those around, I got 1 volt on my signal wire again, just like I had on my right side. And again, the colors are wrong here based on what I'm seeing on the wire. So what's going on here, and I've seen this a lot of times when repair's been done to these vehicles, is somewhere in this harness, these wires have been swapped. There was probably a repair that was done and the wires were crossed, meaning that the power supply to the sensor is going to what should be the ground side and vice versa. And the sensors will not work. It obviously shorts out the circuit and pulls it down to 1 volt, which it's not supposed to do. I just need to figure out where this was done. And this was actually pretty easy on this one. I followed the harness up from the right front sensor into the wheel well, and I could see there was some electrical tape that did not belong. It wasn't factory. Peeled it back and saw that there was a wire repair. So I told the shop, all you need to do is cross these wires, flip them back, do a proper repair, plug it back in, and the sensor is going to work properly. And I verified that the sensor was good by jumping the left front harness to the right front sensor, and there was no circuit code. I didn't drive it, but I believe this repair was done at some point or another, and it was never addressed because they didn't need their 4-wheel drive and didn't care about an ABS light. It's kind of an older beat-up vehicle. At least that's what I'm assuming. And again, they were here because they wanted 4-wheel drive. And it's snowing in winter here, and my 4-wheel drive doesn't work. Can you fix that? Well, they're going to have to address the improper repair that's been done to the ABS system here, and then it'll be good to go. So the point of this is, if these sensors are connected backwards, they won't function. There's a positive and a negative side of the sensor, and you got to make sure that they're connected correctly. Otherwise, you get circuit issues, circuit codes. The sensor's not going to function. Okay, next one is a 2015 Ram 1500. This was one that's setting a circuit code for the left front sensor, wheel speed sensor, and the sensor had already been replaced by the shop, and they're still getting the same code. Okay. So I get into this and I check again at the sensor. I want to see what's going on there. I have ground on one side that lights a powered up test light, just like the last vehicle that we looked at. And on the positive side, I have 10 volts on my signal or positive side of the sensor. Now, as I rotate the wheel on the left front of this vehicle where the code is set, I actually do get a square wave on this signal wire. And I see it on my scope. But the circuit code sets every single time for the left front sensor. As soon as I clear it, it comes back, even though it looks like the sensor's functioning properly. So I'm thinking, okay, well, maybe this is a bad sensor. In this case, what I'm going to do is I'm going to go look at the right front sensor. And again, I use this a lot if I'm not 100% sure the voltage is, or, things appear to be normal, but I don't know what normal is for that particular application. So anyways, I go over to the right front sensor and I connect the same way. I have a ground that lights a powered up test light on the negative side, and I have voltage on my signal or my positive wire of that sensor, but it is closer to battery voltage. Okay, key on engine off, I have 12 volts on this side. And I actually didn't notice the difference right away, but going back and forth, I saw, okay, I have 2 more volts on this side, on the right side in comparison to the left, and the left is the one that's setting the code. Now, why is this? Is it the sensor's fault, the one that was replaced on the left side? Is it pulling it down too far? Or do we have a circuit issue or module issue where it's not outputting the correct amount of voltage? So how am I going to determine this? Again, I'm going to use the right front in order to help me assess the circuit on the left front. Okay. So what I do first is I take my left front harness and I'm going to connect it to my right front sensor with some jumper wires. Okay. So my goal here is to eliminate the sensor that's been replaced on the left front as a possibility for pulling this voltage down below the point where it's supposed to be, or at least that's what I'm assuming at this point, is that 2-volt difference is most likely my issue. I don't know that for sure, but let's connect it up and see what happens. So when I do this, the voltage remains the same. And again, I realize this is tough without a visual, but I'm monitoring the harness, which is connected to the ABS module on the left front, but I've disconnected the left front sensor and connected the right front to it, right? So I'm giving it a sensor that doesn't have a code setting for it, essentially, a known good, if you will, and seeing what happens. And I still have 10 volts over there. And just for reference, because I got my jumper wires out and I have everything disconnected, I take my right front harness, and remember this is the one that doesn't have a code setting, and I jump it over to my left front sensor, which has been replaced, and I still have that 12 volts over on the right front where there is no issue. So that hasn't changed. And again, I'm kind of chasing this, assuming this has something to do with my issue, this 2-volt drop, but it does not appear to be related to the sensor itself. Oh, and I forgot to mention, I'm actually using codes here as well. And it doesn't matter which side sensor is plugged into my left front harness, I still get a circuit code for the left front wheel speed sensor. Okay, so now I really need to address the module/circuit to this wheel speed sensor to try to determine where this 2-volt drop is and if that is my issue. Now, on the left front side, the module is actually up on the front of the frame well on the left front side of the vehicle. So the harness is actually pretty short, maybe 1.5 foot of wire between the sensor on the left front and the module itself. So not a whole lot to look at here. Now it's in a harness, but I do a visual and I don't see anything really obvious here. Now, of course, I could tear apart the harness, but what I'm thinking is I want to test on that positive side of the circuit. I want to test it as close to the module as possible. And ideally here, I'd like to back probe the connector at the ABS module and see if the voltage output is the same as what I measure at the sensor. Is it 10 volts or is it 12 out of the module and I've got some drop somewhere in the circuit? But I can't back probe this connector without disconnecting it. It's a big lever style, and removing the plastic shield that's over the wires at the connector. And we see this a lot on modules, right? You can't see the wires as they go into the connector without removing some sort of cover. And generally they pop off pretty easily, but on the lever style, you're going to have to move the lever, which unplugs the connector from the module, then disconnect this plastic shield, connect the module back up, back probe it, and then measure the circuit. Now, here's why I don't want to do this. If the problem is with the connection at the ABS unit, by disconnecting this, I could fix the problem and then it may go away. And I don't want to do this just yet. So instead, what I decided to do was to open the harness as close to the module as possible, find my wire. It's a green, light green on this one, or dark green, light green on this one. And I'm going to measure the voltage pierced at that point. And I'll fix the wire, the hole that I make in the wire afterwards. But I'm going to get as close to that module as I can and see, okay, am I still getting the 10 volts? Basically, do I need to go towards the module and the connector, or is this problem out on the circuit? Okay, now I do have my 10 volts here as well. So I need to go towards module and connector. And so at this point, okay, I don't have much more of a choice. I'm going to have to disconnect this connector at this ABS module. I do that, I pull the lever, pull this module out. And as soon as I do, I see what the issue is. There's actually water in the connector, and this module's in a pretty exposed place. So I'm not too surprised, but I look at the pins in the connector, and I'm surprised there weren't more problems with this thing, because there was all kinds of green, crusty corrosion on the female side of this connector going into the ABS module. And so I show the shop, hey, there's water in here, there's corrosion in here. You're going to have to either clean or replace this connector. The seal on the connector probably needs to be replaced as well if you don't replace the entire thing. And you're going to have to reassess once you do that, did water and corrosion get into the ABS unit? It's a possibility, but you got to fix this connector first to go from there. Okay, so that's what happened, was corrosion either in those pins in that connector or potentially even in the module were causing a voltage drop on that circuit. And on this particular application, if that voltage drops below a certain point, even if a square wave is being generated, which it was, you're going to get a circuit code. It's looking for something specific on that circuit for that wheel speed sensor, for all of the wheel speed sensors. When the key is on, it didn't see that the voltage was below a certain point, so it set a circuit code. All right, so that was the official fix for that. I haven't heard back from that shop whether it was just a connector or if they needed to do a module. But it's connector first and then kind of see where you're at after that point. All right, finally, last one is a 2010 Toyota Prius. This is actually at the same shop that Ram was at. This one also setting a code for the left front wheel speed sensor. Again, a circuit code. Again, the sensor had been replaced and it did not get rid of this code. You're going to see some repetition here. I'm doing the same thing. I'm checking at the sensor. I have a ground that lights a powered up test light. Cool. Seems to be the case with all of these vehicles. Toyota, Ram, Nissan, all kind of the same thing. On the positive side of the circuit, I have 12 volts measured with my U-scope. When I spin the wheel, I do not have a square wave though. I do not have a changing voltage. It stays fixed at 12 volts all the time. And the circuit code sets. Okay, so let's go over to the passenger side again, see what's going on over there. Again, ground that lights a powered up test light, and I have 12 volts on the signal wire, just like on the other side. Rotate the wheel on that side and you get a square wave. Okay, so what's going on here? Do I have a tone wheel issue? It's the first thing that I look at. Tone wheel appears to be intact. Okay. Is this a sensor issue, right? The sensor is replaced. You get bad new parts all the time. Let's do the swap just like with the other ones. I'm going to connect up the right front harness to the left front sensor in question. Does not set a circuit code on the right front. I measure a square wave. It actually does produce a square wave when I turn the wheel using the right front circuit. Okay, so what's going on with our left front circuit? Why is it a 12 all the time, even if I rotate the wheel? Because that's where I'm at. Now, like I mentioned earlier in the podcast, that voltage change isn't a whole lot when the sensor pulls it down, maybe about a volt and a half difference. So if you're looking at it and you have your scope set up on like a 20 volt scale, the square wave is actually pretty small, but the sensor is pulling down that 12 volts. But we don't seem to be able to do that on the driver's front, the left front side of this vehicle, even though the sensor is capable of doing it when plugged into the right front. So what's going on with either the module or the circuit to this sensor? And my thoughts are maybe there is a voltage source that is shorted to this positive circuit that doesn't belong there. Now, that could be on the circuit itself or it could be in the module. And I'm kind of thinking module, like maybe there's a short in the module, because we mentioned before that if you think of it as kind of like a thermistor circuit, again, I realize there's more complexity to that. There's a fixed resistor inside of the control module for a thermistor circuit, right? So we're not applying that, in the case of a thermistor, 5 volts directly to the circuit. It's going through a fixed resistor, and sometimes that's called a current limiting resistor, right? If we short that that signal wire directly to ground, it doesn't short out the 5 volt regulator in the module because we have that fixed resistor in there, right? And so in our MR style sensor, again, more complexity, but there's some measuring circuitry that is in between the voltage source and the sensor itself. And what that means is in Sean's simple terms, if I take a grounded test light and I touch it to one of these signal wires, it should not light a test light. Okay. I have not seen an MR style sensor where it will do that, right? A ground side, it lights up my powered up test light. And again, I'm using an incandescent test light here. But if I take a grounded test light, right? Clip of my test light is connected to ground, and I connect it to the positive side of any of these sensor circuits that we're talking about. It should not light my test light, and it should pull that supply voltage all the way down or very close to ground. Okay. So I'm going to do that here. I just want to see what happens. Okay. Do we have a short to direct voltage is what I'm thinking, right? Because we can't pull it down with the sensor, but we know the sensor's capable of doing it. There has to be something on that circuit that doesn't belong there. So I do this, ground my test light, negative side of the battery with my test light, and I touch the positive side of the circuit for the left front sensor, and it lights up my test light brightly. Okay. And I verified on the right front, it's not supposed to do that. Okay. The positive side of the circuit will not light up an incandescent test light grounded. That's not normal, but it is. Okay. So now my question is, okay, I do have a full 12 volt battery voltage supplied to the circuit. I'm not supposed to, and that's got to be what's setting the circuit code. So I just need to find it. Now, first thing I would normally do is unplug the ABS control module and see if that voltage goes away. And that would indicate to me that the short is internal to the module. And that's kind of where my mind was going. But the problem with this Prius is that connector on the ABS module is not an easy thing to get to. It is buried under a cowl, and you can't even get your hand down there to unplug this thing. And I'll do that if I have to, but I think what's better in this situation is do a really good visual of the harness all the way from the sensor up to the ABS module to see if there's anything visual where a short could be happening. And I looked at the diagram. There's no connectors in line. It's a straight shot. There's the connector at the sensor, but that's where I'm measuring. And then it's a straight shot to the ABS module through harnesses, of course, but there's no point where I can disconnect a connector. I could, I guess, cut a wire if that's where it comes to. But anyways, I'm just going to do a visual of this harness to see if there's an issue. So I follow up the wires that go in through the wheel well, and then they go behind the area that's behind the left front headlight. Okay. So I shine my flashlight down there and immediately see what the issue is. Someone at some point had changed the headlight on the left front side of this Prius. When they did it, they either did not secure the headlight properly and it fell out of its housing, still connected to the electrical system of the car, or maybe they just didn't put it in there at all. But what had happened is the actual 9000 series headlight bulb had fallen onto the harness, which just happened to contain the wires that went to my left front sensor. Well, the headlights were on as this thing was driving. As you know, a 9000 series headlight bulb gets nice and hot. It melted through the loom for the harness and into the wires inside of that harness and had shorted our positive signal wire for the wheel speed sensor to another 12 volt source. I don't even know what it was for. It didn't really matter at that point. But when I pulled the wires apart, that stopped the short and stopped our circuit code. So I showed the shop, here's your issue. You just need to repair this harness here and you'll be good to go. So that was the fix for that Prius. And again, I just wanted to share that with you. Just some things to know about these circuits, right? Check for the wires being backwards. In most cases that I've seen, check for a ground that lights a test light. I can't say that's always true, but in a lot of applications it is. And the positive side of the circuit should not light a test light. It should be something close to battery voltage, but also remember that there should be a specific voltage on there, like our Dodge. So check the other sensors on the vehicle that aren't setting codes, and they're going to give you a pretty good idea of what's supposed to be there. And use those other sensors, right? Get a reel or a couple of long jumper cables and use those good sensors with your harness in question to determine, is it the sensor, is it the circuit, and then you can go from there. But that's all I got for you today on MR style sensors. Hopefully that information is helpful to you. I'd also like to thank everybody who's been listening to the podcast and providing feedback. I always appreciate that. I'll get back to everybody that I can. If I'm a little delayed, I'm busy, but I will do my best. Other than that, let's all get out there, start fixing the world one car at a time.